Hi guys, welcome to my YouTube channel. Click like, subscribe and press bell icon. Previous video I was explained about the gear and terminology. What is the gear and the gear terminology. Now I start today about the gear train, gear ratio and torque and speed calculation. A gear train consists of two or more gears in series. It is used to increase or decrease the speed or torque of the output shaft. The terms gear ratio is used to calculate the speed and torque of output gear. For example, a gearbox is a type of gear train that is used to increase engine torque and reduce the speed at the car wheels. The increase in torque depends on what gear you are driving your car. There are A, B and C and D. A gear is drive and the D, B, C gear B and C are ideal gear and D is driven. A gear, the rotation is either clock or anti-clock, and B and C idler gear always opposite of your drive gear. D is driven gear. It is the same rotation like A gear. As I mentioned over here, law of gearing. The law of gearing states that the angular velocity ratio between mating gears is always remains constant to achieve the condition of constant angular velocity. Common normal at the point of contact between mating gear teeth always pass through the pitch point, where pitch point is the point of contact between mating gear pitch circle. Here, in the angular velocity of mating gear is constant, we can conclude to the following relation: W1 upon W2 is equal to N1 upon N2 is equal to D2 upon D1 is equal to T2 upon T1, where W and W2 angular velocity in radian per second of drive and driven gear respectively. N1 and N2 gear speed in RPM, D1 and D2 the diameter respectively, T1 and T2 T drive gear ratio. The gear ratio is the ratio of the number of teeth of the driven gear and the drive gear. It is used to calculate the speed and the torque of output shaft when input and output shaft are connected using a gear train. Gear ratio W1 upon W2 is equal to N1 upon N2 is equal to D1 upon D2, D2 upon D1 is equal to T2 upon T1. Gear ratio and speed. Power transmission through gear train affect rotational speed of output shaft. Gear ratio W1 upon W2 is equal to N1 upon N2. Input gear speed upon output gear speed. Therefore, speed of output shaft is equal to speed of input shaft upon gear ratio. As shown above, if the number of gears on the output shaft is greater than gears on the input shaft is greater than gear on the input shaft, this arrangement is also known as reduction gear drive. In this arrangement, the output shaft will have a low speed compared to the input shaft. Whereas when we reverse the arrangement. In the other word, if the number of gear on the output shaft is less than gear on the input shaft, output shaft speed will have a high speed compared to the input shaft, as mentioned in the figure. Gear A and gear B. Gear ratio and the torque. According to law of gear, in the gear train ratio of output torque to input torque is also constant and equal to the gear ratio. Gear ratio is equal to d2 upon d1 is equal to output torque upon input torque. Gear train types and their calculation. There are 4 gear train types: simple gear train, compound gear train, reverted gear train, and planetary gear train. I mention here all 4 points. Let me discuss about it one by one. First is gear ratio calculation for simple gear train. A simple gear train can be of 2 gear train or multi-gear train. 2 gear train. 2 gear train is a type of simple gear train. It is consists of 2 connecting gears, for example, as shown in below, in 2 gear train. There is some questions. Let me discuss about it and calculate the speed and the torque. There is mention teeth of the drive gear T1 is equal to 40, number of teeth of the driven shaft T2 is equal to 20, speed of drive gear N1 is 100, and torque acting on the driver's gear is 10 Nm. Gear ratio calculation. Gear ratio T2 upon T1. Gear ratio T2 upon T1 is 20 upon 40.5. Output gear calculation is speed of output gear, output shaft upon gear N1 upon gear ratio. So overall 100 upon 0.5, this 200 rpm. Output shaft upon gear torque calculation d2 upon d1 is equal, gear ratio is equal to d2 upon d1. Output torque upon input torque. So torque generated by driven gear is gear ratio into torque generated by driver. So 0.5 into 10 is equal to 5 Nm. This is the gear ratio. And the next is multi-gear train. So we discuss about it with the example and question. There is mentioned driver, idler, and driven gear. Let's start to this question. Given number of teeth is T1 40, T2 20, and the gear ratio calculation for multi-gear train. There is 3 steps. Gear ratio between G1 and G2. So the gear ratio 1 and 2 is 40 upon 20 upon 40, that is 0.5. Step 2, calculate gear ratio in between gear 2 and 3, idle and driven gear. So gear ratio 2 and between 2 and 3. 10 upon 20, 0.5. Step 3, by multiplying gear ratio between 1 to 2 and 2 to 3, we will get resultant gear ratio between driver and driven gear. Resultant multi-gear train GR is equal to 0.5 into 0.5. Point this equivalent 0.25. Now gear ratio calculation for compound gear train. There is 3 gear, driver, idler and driven, which those are in a gearbox, and this called it is a type of compound gear train or compound gear box. There's mention T1 is equal to 40, T2 30 and T3 20, T4 10. Gear ratio calculation for compound gear. In the above example, gear 2 and gear 3 are on the same shaft. So first step, calculate gear ratio between 1 and 2 gear. Gear ratio between 1 and 2, that is 0.75, and the step 2, gear ratio between gear 3 and gear 4, that is we calculate here 0.5. Now the third step, multiply gear ratio 1 and 2 and gear ratio 3 and, so the resultant compound gear GR value is 0.375. There is third, reverted gear train. Reverted gear train are a type of compound gear trains in which input and the output shaft are on the same axis. In the above example, gear 1 and gear 3 are on the same axis. They are used to achieve a high gear ratio within a limited space. Reverted gear train gear ratio is calculated simply to compound gear train, like example here. So thanks for watching my YouTube channel. Please share, comment, like and subscribe my YouTube channel. Thank you.